Namaste dear students, hope all of you are well. This is the second lecture of redox reaction. In the first lecture, I had described about what is redox reaction, what are the differentiation between the oxidation and reduction, and what are the rules of redox reaction. In this video, especially, I am going to describe about the category of redox reaction, classical idea of redox reaction, oxidation and reduction, and then I am going to solve some of the numericals. As in the previous video, I had informed you about the oxidation and reduction. If you may have remembered about the oxidation and reduction, then it's very easy. Oxidation, reduction. Here it was, the first point was addition of O2, addition of oxygen. Here the first point was addition of hydrogen. Have you remembered? Now, loses of electrons. Here loses gaining of electrons. If you have remembered then, in the previous video, if you have not seen my previous video, no need to worry. You can go to my channel and you can search Redox Reaction Lecture 1. You will get that video. It's very easy. So no need to worry first of all. So as you have seen, addition of oxygen, addition of electronegative element. Addition of electronegative element. Here and here addition of electropositive elements, third point only. Here also, as we have discussed in the lecture 1, it was addition of electropositive elements. Fourth point was removal of hydrogen. Here it was removal of oxygen. And the last point was increasing oxidation state. And here decreasing oxidation state. So this was the main differences between the oxidation and reduction. I hope that all of you have remembered these things in the lecture 1. So in this lecture, what the main things which I want to discuss with you all is that how you will understand these reactions are oxidation or reduction. As I have said you the rules and regulations that how to first of all understand about the oxidation and reduction. If the reaction will be given below, how you will find that this reaction is oxidation or reduction. Just suppose hydrogen sulfide and chlorine gas. It mixes and becomes hydrochloric acid and sulfur. Okay. Now tell me how you will understand that this reaction is redox reaction or not. Which elements is getting oxidized or which elements is getting reduced. So generally you know very well. I hope that you know this thing, that addition of hydrogen, you can generally say this is the addition of hydrogen in chlorine, so this is the reduction. And here there is nothing, so addition. Sulfur is there because here oxygen is not added, so you can't say this is oxidation. But I am saying you must know the oxidation state. Here there are two hydrogen valency or oxidation is +1 here. So two hydrogens are there, so +2 and sulfur -2. Because 2 here is there, so 1 into 2. 1 into +2, that is going to +2, right? So here chlorine 0 is there. Here hydrogen +1, chlorine -1, sulfur 0. So you can see from -2 to plus. -2 to 0 is oxidation. And here 0 to -1 is reduction. So here both the phenomenon is there in this reaction. So you can say yes, this reaction is redox reaction, right? Second one is, if I talk about phasopheric acid. You know, first of all, FeO plus Fe2O3. This is ferrous acid and ferric acid. Ferrous oxide, ferric oxide. They both mix and become phasopheric oxide. This formula is written like Fe3O4, but it is generally, if you ask, it is written like this: Fe2, FeO and O3. So you can count here 3 iron and 4 oxygen. This is known as phasopheric acid. Now you can tell me here that here the iron valence is +2, oxygen -2, here also +3 and -2. So 3 2 ja +6 and -2 3 ja -6. So you can see here that these are the balanced reaction, but here in this +3, +2 and -2, these all are -2. Both are there, but they both are combined. So when this type of reaction comes, so you can generally say that here both the reaction are mixed and both the oxidation states are there. Okay, so that's why it's known as phasopheric acid. Only for the phasopheric acid there is no redox reaction. But if anything is added in this phasopheric acid, like your NCERT question is there, Fe3O4 plus 8Al. 3 Fe3O4 plus 8Al aluminum gives 9Fe plus 4Al2O3. Right? Now you can say here that here 0, here iron exists in +2 and +3 both oxidation state. Aluminum here exists in 0 oxidation state. So from +2 to 0 it is reduction, and here 0 to +3. +3 2 ja -6 and -2 3 ja -6. So here you can say that this is increasing, so it is oxidations. So you can say this reaction is redox reaction. And the third question of the NCERT is about sodium plus hydrogen. 2 sodium plus hydrogen gives sodium hydride. So here also you can see they both are existing in 0 oxidation state. Here sodium +1, hydrogen -1. 0 to +1 oxidation and 0 to -1 reduction. So this reaction is called redox reaction because both the phenomena are there. The most important thing in this video that you should learn that how to understand the oxidation state. Remember, as in the previous video, if you have not seen, go and see the previous video. In the previous video already I had informed that how to balance the compound oxidation state. All the compounds oxidation sum should be 0. Any compound is there. There sum should be, as for example here you can see +2 and -2. If you will add this both the number, it will become 0, ferrous oxide. Here also you can see iron exists in +3. There are 2 iron, so +3 2 ja +6. Oxygen in 3 molecule -2 3 ja -6. +6 -6 you can see here. So dear students, whenever you understand the oxidation states of any element in compound, then it's very easy that you should know that it is oxidation or reduction. Only remember the main thing that increasing oxidation state is called oxidation, decreasing oxidation state is called reduction. The main important topic that you should remember whenever you are balancing or you are doing this type of reaction, that what is oxidation and what is reduction. Now the main important thing, that redox reaction in the terms of electron transfer, as I have taught you. How you will remember that how many loss of electron or how many gain of electrons are there. Here as I have written here, losses of electrons and gaining of electrons. If I give you some of the reaction, So can you tell me how many electrons that element had lost, or how many electrons that element has gained? As our next topic in the NCERT is that to balance or to manage by the transferring of electron, that reaction is a redox reaction in the terms of transferring of electron. Our first question is sodium plus chlorine. Give sodium chloride. Sodium 2Na plus Cl2 gives 2NaCl. Right? Here sodium is also existing in zero oxidation state, chlorine is also. Here sodium has lost 2 electrons and chlorine has gained 2 electrons. Well, there are 2 compounds, but remember here the oxidation states is +1 and -1. Because it is a 2 compound, so here sodium has losses of 2 electrons. Losses of 2 electrons. And here gaining of 2 electrons. Gaining of 2 electrons. So in this way you can directly say by the transferring of how many electrons it has become +1 or -1. So since 2 atoms are there, so +2 and this is -1. So now you can say here from 0 to +1 sodium will become oxidation, because the oxidation state has been increased. And if I talk about 0 to -1, here the oxidation state has been decreased. So this is reduction. And one more main formula, by gaining of 2 electrons from 2 atoms of sodium, it became 2 chloride atom, and by losing of 2 electrons from sodium, it became sodium plus ion. So here you can say that how these elements are forming and how many electrons they are losing or gaining. Similarly, the second reaction is 4Na plus O2. 4Na plus O2. Na2O. You can see here sodium oxide. Similarly, if anybody will ask you that how many electrons sodium has lost here. So there are 4 sodium atoms, 1 electrons each sodium has lost. Here you can say it's -2 and this is +1 only. So 2 atoms are there. So here 4 sodium atoms are there. So there is the losses of 4 electrons. Losses of 4 electrons. And here gaining of 4 electrons. Gaining of 4 electrons. Now you can see, sir, here both the elements are existing in zero oxidation state. From 0 to +1, 0 to +1 what it will be? 0 to +1 oxidation, and 0 to -2 reduction. So dear students, in any way if you want to calculate that this reaction is a redox reaction or not, so the 2 main formula you should remember, that by the addition means gaining of electron and by the removal means losing of electrons. So losses of how many electrons and gaining of how many electrons. Now oxidation means loss of electrons by any species, and reduction means gain of electrons by any species. And oxidizing agent means acceptor of electrons, acceptor means gainer of electrons, and reducing donor of electrons. So the 2 things which I have already cleared in the previous video, that what is the relationship between the oxidation and reduction is that you should remember always that oxidation means losses of electrons and reduction means gaining of electrons. So here oxidation, reduction, oxidizing agent and reducing agent. These 4 things you should always remember whenever you are going through this chapter. Oxidation means loss of electrons by any species. By any species. means by any elements, if the element is losing their electron, that means it is oxidation. Gain of electrons by any species. Oxidizing agent means reduction, gaining of electrons. Remember dear words, as I have written here in the terms, oxidation means loss of electron by any species, reduction means gain of electrons by any species. If I talk about oxidizing means acceptor of electrons. Acceptor means gainer, acceptor of electrons. And donor of electrons is reducing it. So here are the two things which you have learned: oxidation, reduction, oxidizing agent and reducing agent in the terms of transferring of electron. So here there is one numerical. Justify that reaction is a redox reaction. How you will justify that this reaction is reduction? 2 sodium plus hydrogen. 2 sodium plus hydrogen gives 2 sodium hydride. So as already I had informed you, here sodium has loss of 2 electrons and gaining of 2 electrons. Loss of 2 electrons and here gain of 2 electrons. Now you can say me here, sir, both the elements are existing in zero oxidation state. Here plus 1 and minus 1. So we can say like these also, 0 2 plus 1 oxidation and 0 2 minus 1 reduction. So when both the terms are there in this reaction, hence this reaction is redox reaction. You can solve like this also. Now we are moving towards the next topic, that is competitive electron transfer. Competitive electron transfer reaction. Electron transfer reaction. Now dear students, now in the terms of ionic reactions, or you can say electrostatic part of this redox reaction, if you are placing a strip of metallic zinc in an aqueous solution of copper nitrate, just remember dear students, if you are putting anything in the reaction, then what will happen? That is the main term, that how you will understand that in this reaction which terms you are adding and what things happen. So if you add a zinc blade in copper sulfate solution, what will happen? Or copper nitrate solution. Here in your textbook it is given about the copper nitrate. Just suppose that this is a test tube. In this copper nitrate solution is there, and here I have placed a zinc metal rod. Zinc rod. Okay. Now tell me what will happen. First of all, you should know the color of copper nitrate. Dear student, when I talk about copper, either copper sulfate or copper nitrate, always remember the color of this solution is blue. As I dipped this zinc rod, so now what will happen? The blue color will become faint blue. Faint means, you know, fika. Fika pad jana, as you know, dark blue, faint blue. Similarly here, as the blue started becoming faint, means it is reducing the blue color. And finally you will see that copper has deposited on the zinc metal. Means copper has deposited on the zinc metal, means this copper nitrate first of all has turned into Cu plus and NO3 minus, and here the copper layer has occurred on this zinc rod. What had happened? Generally, as you have seen in the 10th standard also, in the electrolysis also, if I talk about copper sulfate solution, just suppose Cu2 plus and sulfate 2 minus, right? And here the two electrolytes are there. In the electrolysis process we have studied also. Here there is a copper sulfate solutions. Okay. Now the zinc rod, in the terms of zinc rod, the losses of 2 electrons from the copper will deposit here. Means on the copper electrodes, the 2 electrons will be, copper's 2 electrons will be deposited on the zinc electrodes. Now you will say me here, sir, now the zinc rod will become zinc sulfate or not? Yes, the zinc rod will be converted into zinc sulfate. Or if you understand one more thing, if I just want to tell you that if any solutions are there, how they are being converted. So dear student, the solution is not going to evaporate. The solution is going to remain same. But the terms, there will be loss of electrons and gain of electrons. Now question is, in which electrodes there will be loss of electron and which electrodes there will be gain of electrons. So whatever the rod is there, if that rod is more electropositive than the solution's ions, then it will be deposited, as you have read in the 10th standard about the metal reactivity series. Have you remembered? From potassium till gold or platinum it was there. So hydrogen was the main term. Here we will discuss about the electrode potentials. Which element can gain electron, which element can lose electrons. So these are all the things we are going to understand in this topic. So in the reaction you will see that there will be a loss of electrons to form zinc 2 plus, therefore zinc is oxidized, and when there will be loss of copper 2 plus, means copper has disappeared. If hydrogen sulfide gas is passed through this colorless solution, then zinc 2 plus ion will appearance. As here you can see that as I have put the zinc rod in this copper nitrate solution, as it has started becoming faint color, means from blue to faint blue, and when here I have passed hydrogen sulfide gas, so here it will become colorless and zinc will get zinc 2 plus, means zinc will convert into Zn2 plus. First of all, the 2 electrons from the copper zinc has obtained, and now the zinc had removed 2 ions from it and it becomes zinc sulfide. So the solution is just like alkaline with ammonia. Now if I'll give you any type of reaction in this electropositive elements, I hope that you should remember that which type of reaction is that. You should remember the metal activity series. If you will not remember the metal activity series, then there will be a difficulties. Now first of all, how to calculate the oxidation number, as I had taught you in the previous video. In this video, balancing of redox reaction. First thing, I will give you some steps of how to balance the redox reaction. Balancing of redox reaction. How you will balance the redox reaction. Our topic is balancing of redox reaction. Balancing of redox reaction. By which method? Oxidation number method. By oxidation number. That oxidation number means oxidation state only. By oxidation number method. There are some steps. If I talk about the step number 1. What is the step number 1? If anybody will ask you how you will balance. If there is unbalanced ionic equation, means skeletal ionic equation, then remember, dear students, first of all write the net ionic equation for the reaction of, if I talk about the potassium dichromate with sodium disulfide in an acid solution to give chromium 3 ion and the sulfate ion. Means what you have to do, you have to write chromium, potassium chromate plus sodium sulfite. It will give you the chromate and sulfite ions. Skeletal ionic equation. Skeletal ionic equation. Skeletal ionic equation. You know K2Cr2O7, right? What is this potassium dichromate? It turns into 2K plus Cr2O7 2 minus, right? Sodium sulfite Na2SO3 will turn into Na2 plus Na plus 2Na plus and SO3 2 minus. Sodium sulfite Na2SO3, it will turns into 2Na plus and SO3 2 minus. Now tell me about this Cr2O7 2 minus plus SO3 2 minus. SO3 2 minus. What will happen in this reaction? Can you tell me? What will be the oxidation state of chromium? What will be the oxidation state of sulfur? So here you have to, what you have to write, that here first of all chromium has been dissociated. Means how this reaction has turned? The reaction has turned into chromium 3 plus and sulfate 2 minus. Chromium 3 plus and sulfate 2 minus. Now it is an unbalanced reaction, that's why I have written here the skeletal ionic reaction. Now you have to assign the oxidation number of chromium. What is the oxidation number of chromium in this reaction? Step 2 is you have to assign the oxidation number. What is step 2? Assign oxidation number or oxidation state, whatever you think. Now can you tell me what will be the oxidation state of chromium and sulfur? How you will assign? For chromium and sulfur, it will be plus 6 minus 2 plus 4 minus 2 plus 3 plus 6 minus 2. Right? Means if I talk about Cr2O7 2 minus plus SO3 2 minus, and I have written here Cr3 plus and SO4 2 minus. So what will happen here? Here if I talk about that what is the oxidation state here? Means as I have already informed you about the stop notation, means this whole reaction Cr2O7 2 minus, means if you don't know the oxidation state of chromium here, just suppose let the oxidation state of chromium be X. So here 2X plus oxygen is minus 2 into 7 is equal to minus 2. 2x is minus 14 is equal to minus 2. 2x is equal to minus 2 plus 14, that is equal to plus 12. And x is equal to 12 upon 2, that is equal to 6. So here the oxidation state of chromium is plus 6. Means plus 6 is there. So there are 2 chromium. So here it will become how much? Plus 6. So plus 12 it will become, and minus 12. So 14, and it will be equal to 2. Yes. Similarly, if I talk about here sulfur, I don't know, then what you will do here, x plus minus 2 into 3 is equal to minus 2. Here the sulfate will be plus 4. How? I am showing you. If I calculate sulfur as a x plus minus 2 into 3 is equal to minus 2. X minus 6 is equal to minus 2. X is equal to minus 2 plus 6, x is equal to plus 4. So here I have written that is a plus 4 oxidation state of sulfur. So in the second step, what you have to do? You have to assign. What you have to assign? The oxidation number. And in the third step, calculate the increase and decrease of oxidation number and make them equal. Increase and decrease. Third step, calculate the increase and decrease of oxidation number. Now, in the third step, what you have to do? Calculate the increase and decrease of oxidation number. Third step is calculate the increase and decrease oxidation number, right? And balances as I have written here, Cr2O7 2 minus plus SO3 2 minus is equal to 2Cr3 plus and plus SO4 2 minus. So is this reaction balanced? You can see here the reaction is balanced or not. 2 chromium, 7 and 3, 10 oxygen, right? So is this reaction balanced? Yes or no? This reaction is not balanced. So what you will do? You have to write 3 on the sulfide side and 3 on the sulfate side. Here 3SO2 and here 3SO4. Now you can see. So 3 3s are 9 and 7. 16, right? You can just calculate what will happen here, you know. I am saying you what will happen. As we have increased and decreased the oxidation number in the left side and right side. In the left side in this reaction, the oxidation state of chromium is +6 and right side it's +3. And in the left side, +4 sulfate, and that right side, what is the oxidation state? Can you tell me? +6. So here +4 to +6, sulfur has been oxidation and chromium has been reduction. So what we have to do in the fourth step, balance the charge by adding hydrogen as the reaction occur in the acidic medium. So here Cr2O7 2 minus plus 3SO2 minus plus 8H plus. Here what I have done? Plus 8H plus. So what will happen? Why I am adding 8H plus? Here as I will add 8H plus, now you can convert the remaining oxygen into water. Addition of hydrogen and addition of oxygen, these both are valid to form water compound. So you can add whatever the amount of hydrogen and oxygen is required to balance the chemical reaction, you can do that. So here the fourth step is balance the charge by adding hydrogen as the retain occurs in the acidic medium. Now if it wants to retain that solution in the acidic medium, so I have added that 8H plus. And now the reaction became 2Cr3 plus 3SO4 2 minus. Now the fifth step is balance the oxygen atom by adding water molecules. Now here if you want to just balance this, then there will be nothing. You can see here 4H2O will be there. Now just see 2 chromium, 3 sulfur, 3 sulfur. How many oxygen? 7 plus 9 plus 7, 16. 4 3s are 12 plus 4, 16 oxygen, 4 2s are 8 hydrogen. So here what we have learned, that if you want to balance any ionic reaction, any ionic redox reaction, the first step of you have to mention the skeletal ionic equation. Second step is that you have to mention or assign the oxidation state. Third step is calculate the increase and decrease of the oxidation state. Fourth step, addition of hydrogen, and fifth step, addition of oxygen. That time you will see that your main reaction is balanced or not. So this was the main step of balancing a redox reaction. And there are one more reaction that is called half reaction method. If there is a half reaction method, how you will maintain the half reaction method? That is also very good question, that how you will understand the half reaction method. by half reaction. What is this half reaction? Can you tell me? What do you mean by half reaction? Balancing the equation showing the oxidation state of like iron 2 plus to 2 3 plus dichromate ions by the acidic medium where chromate ions are reduced to Cr3 plus. So it's half reaction. Half reaction means that if the reaction is unbalanced, just suppose I am taking, produce any unbalanced equation in the acidic ionic form. Acidic ionic form means that just suppose here iron plus chromate ion I am taking, just suppose iron plus chromate ion. Iron is in here plus 2 and Cr2O7 2 minus, and here I give you that iron has converted into plus 3 and chromate has been also converted into plus 3. Now just suppose this reaction, it is an unbalanced reaction. Now you have to separate the equation into the half reaction. What is this half reaction? Half reaction is that you can see here iron has been converted into plus 2 to plus 3 and chromium has been converted into plus 6 to plus 3. So what do you understand? Plus 2 plus 3 oxidation, half is plus 2 means if I talk about iron, just suppose here iron 2 plus to iron 3 plus, right? Iron 2 plus to iron 3 plus, what it is that? I have separated the half reactions. In the reduction half, you will see that how we will balance the atoms other than oxygen and hydrogen in the half reaction individually. Means except the hydrogen and oxygen, how we are going to balance the reaction. For reaction occurring in acidic medium, you have to add water to balance the oxygen atom and hydrogen atom to balance. You have to just put this water and it will become in the acidic medium. So what will happen in this reaction, you will not be able to understand here. So here just suppose that if I talk about Cr2O7 and it has converted into Cr3 plus, then you can ask me, sir, what about this oxygen? Where this oxygen? So that's why we have to add water molecules. Means if I talk about Cr2O7 2 minus, here it will be Cr3 plus and plus H2O. Why I have added here water molecules? You can ask me, sir, what is the need to add water molecules? Then I will tell you here that, dear student, if we are adding hydrogen this side plus 14H plus, then here plus 7H2, you can see 7 oxygen, 14 hydrogen, and it has been converted into, here it was 2 chromium. So here you can see, so chromium has been converted from plus 6 to plus 3 oxidation state. So adding of electrons to one side of the half reaction to balance the charge, if need, we make the number of electrons equal in two half reaction by multiplying one or both half reaction by appropriate coefficient. Appropriate coefficient means whatever the number of atoms and molecules are there, that time you have to add that both the reactions should be equal. Okay, we add the two half reactions to achieve the overall reaction and cancel the 3 electrons on each side. This gives the net ionic equation. Net ionic equation. Just suppose here that if I want to just balance this equation, then what I will write here, and what happens? 6Fe2. 6Fe2 plus Cr2O7 2 minus plus 14H plus gives 4Fe3 plus. 6Fe3 plus 2Cr3 plus 7H2. Can you tell me that this reaction is balanced or no? Just tell me that this reaction is balanced. You can see here 6 iron atoms, 2 chromium atoms, 7 oxygen and 40 nitrogen and 7. So this reaction is balanced. So to balance any unbalanced reaction of any two reaction here, if two reactions are unbalanced, just suppose this was one reaction and another was of this iron one. So if two unbalanced reaction you have added and you have balanced this reaction by adding hydrogen and water molecules. So now we have finally completed the half reaction method by the sixth step. In the first step, we have to just produce unbalanced equation. The reaction must be in the ionic form. Second, you have to separate the equation into the half reaction, oxidation half and reduction half. Third, you have to balance the atoms other than oxygen and hydrogen in each of the half reaction individually. Fourth, for reaction occurring in acidic medium, you have to add water to balance oxygen atom and hydrogen atoms. Fifth, you have to add electrons to one side of the half reaction to balance the charge if needed by the number of electrons equal in the two half reactions by multiplying one or both half reactions by the appropriate coefficient. And finally, we add the two half reactions to achieve the overall reaction, cancellation of 3 electrons on each side, and gives this Ionic equation. So this was the half reaction method. A redox couple is defined as having together the oxidized and reduced form of a substance taking part in the oxidation or reduction half reaction, represent as Zn2 plus upon Zn and Cu2 plus upon Cn. Means a redox couple Zn2 plus upon Zn and Cu2 plus upon Cn. So can you tell me this reaction is a couple redox reaction, redox couple. What is this redox couple? In the oxidation reduction half reaction, we have to represent this Zn2 plus slash Zn and Cu2 plus slash Cu. So here this will be our electrochemical cells are devices which are used to get electric current by using chemical reaction. In the next video we will discuss about the electrochemical cells, how the electrochemical cells are being used, and the things which we have forgotten from the NCERT will follow NCERT also in the next video. So this was the just step to remember about the balancing of redox reaction. This whole lecture is based on balancing of redox reaction by half reaction method and by oxidation number method. Hope all of you have liked this video. If you have enjoyed this video, then don't forget to like and subscribe the channel. Share this video with your friends so they can be also benefited. That's all for today. Thank you very much.